Hi guys, I hope you are fine. Me too, I'm fine. Once again, I come to you guys. We continue with binomial distribution. And guys, for this lesson, I will be able to demonstrate something that is concerning binomial distribution. Not actually demonstration, but to be able to give some basics of binomial distribution. So before we go to the question, guys, let's look at the conditions for binomial distribution. And the conditions are that the number of trials should be finite. That is, we are not supposed to apply binomial distribution for infinite trials. That is to say, trials that are up to infinity. Then the trials are independent. That is, they are independent of each of one another. That is, they don't depend on one another. The outcome does not depend on the previous outcome. Then the next one, only two possible outcomes. This is another condition whereby it is either success or failure. That is in regard to performance. Or you can have defective item or an item in good condition. What we are talking about, there are supposed to be two outcomes. For example, in tossing a coin, you could have head or tail. Then the next one is that probability of each outcome is constant. This means the probability of each outcome should be constant. For example, in tossing a coin, the probability of getting a head is a half, the probability of getting a tail is a half. So it should remain the same. That is the probability of getting a head always should be a half. Then guys, we come to general formula. For the general formula, this is what we have, guys. And this is where I had made a mistake. Where I had written q raised to r minus 1 is actually n minus r. So this is the general formula. And this one is represented, for example, we are saying where n is the sample size, r is the number of trials, and p is success, q is failure. This one depends now on the question that has been asked, guys. So if they are like defective equipment, then p can represent defective, q can represent good condition or not defective. So we go to the question now, guys, and read and see what we are supposed to do. And the question reads, 40% of resistors produced by machine are defective. In a random sample of 10 resistors, determine the probability that 3 resistors are defective. So when we go to that question, we are told 3 resistors are defective, and that is represented by R. Here the total sample size is 10. Then P, the probability of being defective, we are told is 40%. 40% in terms of when you cancel 40 over 100, you get 0.4. That is for being defective. So the other percentage is 0.6 because the total probability should be 1. And so this one is going to be 0.6. That is probability of a resistor not being defective is 0.6. So when we say exactly 3 are defective, then we shall have 10 combination 3. And then 0.4, that is defective, probability of being defective. You put 3 there, and here 7, that is 10 minus 3, you get 7 there. So when you do that maths, you can do your maths, that is going to be 120. Multiply by 0.064. When you raise 0.4 raised to 3 is that. raised to 0.6 raised to 7, you get that. So finally, our probability of 3 resistors being defective is 0.213, and it is here, guys. Then the next question is, at least 2 resistors are defective. When we say at least 2, this is what it means. That X is either equal or greater than 2. So that's what we are going to do from P2, P3 until P10, because all the resistors are 10. This, in other words, is the same as writing 1 minus the probability that 0 are defective and 1 is defective. That is what this one means. And so instead of using this one, which is lengthy, we can use this one, which says that 1 minus, because the total probability is 1. Then if we minus that 0 resistors are defective, 1 resistor is defective, then when we minus that, this is now what we get. We get at least 2 resistors are defective. And that's what I have done. I have gone now to find the probability that at least, not at least, but there is no resistor that is defective. And this is the 0 represent no resistor that is defective. I'm a 0 resistant defective. And so this is now how you do it. Defective 0.4%, 0 resistant effective, 10 resistors in good condition. Then when you do that, you get that. You go now probability that 1 resistor is defective. This is what you get. Probability of being defective is 0.4. Probability of not being defective is 0.6. So you multiply there by 9. Here you multiply by 1. And so guys, you get your answer as that. So guys, now you add these two. But after you have added those two, now you come and take away from 1. So it will be 1 minus that. So guys, you will get this answer. You will get your answer as this. So the probability that at most 3 resistors are defective is actually this. So guys, that's how you go about this problem. So I want to thank you so much for just listening to me. As I said earlier, I had done this video, but due to some problem, in fact the problem was here in the equation. Maybe I can show you where the problem I had is actually I had put this as r minus 1, and that made me repeat all these videos. And so guys, sometimes it happens because we want something perfect. We want something that is with credibility, because this is something that is for lifetime. And guys, I thank you for subscribing to my channel. Thank you all people from Africa, from United States of America, from India. I see that you are watching my videos, and I'm so grateful. Despite some of you not subscribing, I still thank you for contributing to my watch hours. And so guys, thank you so much. I still encourage you to subscribe so that I can continue to bring you more content. And I'm very happy. So God bless you and have a nice day. Bye bye.